Hey everybody, today I'm going to be talking to you guys about the BreadthFirst search, right? So let's say for instance, you have some sort of decision tree or option tree, right? So let's say we have here, we have option one, right? But option one can potentially have two or more other options, right? So let's say we have option two and option three. And like this. Okay, and they can actually be interwoven, they can be webbed together or whatever. And let's say let's say option one can go to option two or three, right? And then we can say, for instance, that option two might have several other options. Okay, so maybe a couple options like this. Okay, so we have more and more options that are going. And so these would be like 4, 5, 6, 7, and 8, and so on and so forth. And sometimes they can actually loop back to each other. This can actually be really can get kind of complicated. Let's say 2 and 3 can go to 6, okay, and so on and so forth, like that. Now, these trees can often be really deep, right? There's often a lot of different nodes in them, all right? So each one of these squares is considered to be a decision node. And so the problem is, like, typically you'll get some sort of problem, and it's like, how do you get to a certain destination node? Like, what's the best way, right? Well, what you can do is you can actually do something called a depth first search. Okay, so if we're doing depth first, what we're going to do is we're going to start exploring pathways and see how deep they go. All right, so what we might do is something like this. We go like 1, 2, 3, 4, and then blah, blah, blah down the chain. And if that doesn't work, then you go 1, 2, 4, and then down this way. Right, and if that doesn't work, then you go 1, 2, 5, and then down this way. Right, and then 1, 2, 5, and down this way, and 1, 2, 5, down this way. And that's typically how most recursive type solutions will work if you are going to use something called a depth first search. All right, a breadth first search is a little bit different. Well, it's quite a bit different. All right, so we're going to talk about breadth first. Okay, now breadth basically means width. So what we are going to do is we are going to look in this row here, at this level, and see if there's a solution. And if there's no solution there, then what we will do is we will go to this row and look and see if there's a solution there. And given that there's no solution there, then we'll go to the next row and we'll search row by row. Now, a weird thing though is, like, how do you actually go and search row by row? Okay, and basically what happens is you have essentially a pathway queue. Okay, typically it's another array, right? And so we'll just label this way, pathway queue. All right, and the way it works is that when we populate this, what we do is we say, okay, we look at number 1. Okay, so we're going to look for 1. All right, and then we say, okay, well, where does 1 lead to? So if 1 is not there, then maybe it's 2 or 3. So we look at it and see, like, okay, so 1 can lead to 2 or 3. So what we do is we say, where is our current path that we're looking at? Okay, so we go down here and say current path. Okay, and I'll just draw a line, an arrow pointing to it here. Okay, so currently we're looking at this top level, right? We look at this node and we say, okay, could it be number 1 that's in the current path? No, number 1 doesn't lead us to our destination. So then what we do is we say, okay, where does 1 lead? 1 leads to 2 and 3, and so we add those to our pathway queue, which is typically an array. All right, then what happens is we move on to 2. All right, and we say, okay, so now we're down here looking at this level. Well, let's say 2 doesn't lead us to our destination either. Well, where does 2 lead us to? Well, 2 can take us to 4, 5, or 6. All right. And then, given that 2 doesn't lead us, what we do is we go to our next path, right? So we go to the queue here and we're like, okay, what's next? All right, well, 3. Well, now 3, you can see what we've done is we looked at the other side of this level, right? And so then we can say, okay, well, if 3 doesn't lead us anywhere, then where does 3 go? We add that to our queue, right? And so 3 leads us to 6, 7, 8. All right, but one thing we do is we don't add the same paths over and over again, right? So because 6 is already in the queue, we don't add it again. So we go 6, so we go just 7 and 8. And the reason why you don't add it again is because sometimes you can get the program stuck in a loop, right? So what can happen is that you could say like, okay, well, let's say I go to 2 and 2 leads to 6, and then 6 leads back to 2, and then 2 goes back to 6, and you can get stuck in a loop. The other thing is that let's say I can go, in this case, 1, 2, 6, right? Well, there's possibilities, like let's say I could go 1, 2, 6, 9, and then back to 2 or something like that. Well, if I can get back to 2, then why would I go back there? I was already there, right? So that's not going to be the shortest path if you have already been to that node, right? So the shortest path would not require you to revisit the same node over and over again. All right, so anyways, then given that if it wasn't 3, then we would just go down and we go to the next one, which is 4, and then 5, and then 6, and 7, and 8, and we would just keep doing this and adding items to the pathway queue until we actually found the actual solution that we were looking for. Right. Typically, what this type of solution is used for is when you're finding, like in a decision tree, you're finding the shortest path. You can do this recursively by doing a depth-first search, but the problem is that those types of searches, that type of solution will typically take a very long time, and so it won't be able, your program very often has a time constraint on it or whatever, or the tree is very deep or very complicated, and so like it could just take like a very, very long time to explore everything. Like I'm talking like, in the hours type range at times, right? So imagine if this was like some sort of structure that had like 1,000 levels in it, and each node would lead to like potentially 2 other nodes, right? It's possible that you could find the solution very quickly using a breadth-first search, but using depth-first search, I guess it's possible you could find it early, but a depth-first search will just take a very, very long time to explore an entire branch all at the same time. Anyways, I will link an example problem using breadth-first search in the description. Remember, if you have any questions, throw them into the comments. Don't forget to like and subscribe to the channel. Thanks for watching, and I'll see you next video.